So let us start with a failure that looks like success. Let's say we built an internal policy assistant. Employee asks, what changed in the enterprise refund policy after April 2025? Answer comes back clean. Enterprise customers now get 60 days for refunds, restocking fees removed, and manager approval is still required for everyday refund. Bullet points, citations, all looking proper. But now look at the evidence. The 60-day part is from the new policy. The approval for every refund part is from the old policy. The new policy actually says approval is needed only above 10k dollars. So the model did not invent nonsense from nowhere. It did something more annoying. It mixed two real documents and produced a wrong answer. And that is the scary version, right? Every individual box worked. Embeddings, vector search, the LLM, even the citations looked fine. Nothing threw an error. So what failed? Not the LLM alone. The evidence path failed. At high level, RAG is not put a vector database next to an LLM. RAG is control over evidence. What can be found, what gets ranked, what fits into context, and what the model is allowed to claim. So let us build this assistant by breaking each gate, then fixing it. First, let me just make the word concrete because the acronym hides a very simple idea. RAG, Retrieval Augmented Generation. At high level, the model already has one kind of memory. Inside it waits from training. And then we give it a second memory outside the model. One we can search and update whenever we want. And why do we even need the second one? Because the company policies, support docs, pricing pages, release notes, all of that keeps changing after training. So instead of hoping the model memorized it, we fetch the relevant evidence at the answer time and put it into the prompt itself. So the model is not answering from memory only. It is answering with evidence we fetched right now. And that also tells us when RAG is overkill. If the entire knowledge base fits cleanly in the context window, maybe just put it there or cache the prompt. No need to build a retrieval system just because it sounds more like AI. That is completely overkill. RAG starts making sense when the evidence set is too large, too changing, too permission, or too expensive to carry around every time. For our example, let us say the company has 100k internal documents. After parsing versions, tables, PDFs, and policy pages, maybe that becomes 5 million searchable chunks, and the user expects the answer to start in under 2 seconds. Now the real problem is visible. The model can only see the few chunks that we place in front of it. So the whole system lives or dies by that one question. Did the right evidence make it to that small tray in the right form? That is RAG. Not the vector database, the evidence path. Before search ever runs, we do something very destructive. We cut documents into chunks. And this sounds like boring pre-processing, but it is not. Chunking is where we decide the smallest piece of knowledge our system is allowed to find. Think about our refund policy. Top of the page says refund policy V3.0, effective April 15, 2025, enterprise annual contracts. Then lower down it says refunds are allowed for 60 days. If we cut the document badly, that sentence becomes its own chunk. Refunds are allowed for 60 days. Nice clean sentence, easy to embed, but it lost its identity. It no longer says which policy, which date, which customer type, or whether it replaced the old policy. So when the user asks what changed after April 2025, this chunk might be the exact evidence we need, but the retriever cannot tell. It is holding a fact without its passport. This is why just use chunk size 500 is not a design. Smaller chunks are easier to retrieve for exact facts, but they lose surrounding context. Bigger chunks preserve context, but they drag in noise and waste the context window. Overlap helps sometimes, but it is not free either. So the fix is not one magic chunk size. The fix is to preserve identity. Keep headers, include section titles, attach dates, versions, policy type. Sometimes prepend a small generated context line before indexing the chunk, like this chunk is from refund policy V3.0, effective April 15, 2025. For enterprise annual contracts, now the same sentence becomes searchable and interpretable. Anthropic published a useful example of this in their evaluation. Adding contextual information to chunks moved top 20 retriever failure from 5.7% to 3.7%. Do not treat the number as universal, but the mechanism is the point. They did not make the LLM smarter, they made the evidence findable. First anchor line, the chunk is not the document, it is the evidence unit we choose. If we choose it badly, the rest of the RAG is already playing from behind. Okay, let us say our chunks are decent now. Next naive move. Take the user's question, embed it, search. Simple. The user asks what changed in the enterprise refund policy after April 2025. And search returns refund looking documents, new FAQ, old FAQ, a sales note, all plausible. But notice, none of that actually answers the word changed because changed is not a search term. It is a request for the comparison. It quietly means find the old policy, find the new one, line them up, and care about the date. And that hidden work is obvious to a human. It is not obvious to a retriever unless we ask for it. So, a production system actually needs a small planning step, not a giant agent rabbit hole, just enough to turn the human question into actual retriever workflow. Find the new policy, find the old one, find the change log, and keep exact terms like enterprise and April 2025 instead of paraphrasing them away, and permissions it here as well. If the employee cannot see finance only policies, they should not even enter the evidence path. Do not retrieve forbidden evidence and then hope the model behaves. That will bite us someday. Second anchor line, the question is not the query. Now we get to the part most people call RAG, retrieval. And honestly, this is where the annoying surprise showed up for me. You would think the modern embedding model just wins here, right? It understands meaning. BM25 is this exact keyword thing from the 1990s, basically counting words. But let's say the corpus is enterprise stuff, policies, tables, finance stocks, IDs, dates, exact values. On those boring keyword algorithm from the 90s, beat the state of the art embedding model. These are recent financial RAG benchmarks where BM25 outscored the best dense retrievers on those documents. And once you see why, it makes sense. Dense retrieval is great when the words are different but the meaning is similar. If the user says money back rules and the document says refund eligibility, embeddings help. But our answer may depend on exact handles. RP 2025-04, April 15, 2025. Enterprise annual, 10K dollars, one row in a table. Dense search can miss these because it is looking for meaning neighborhoods. BM25 is boring, but boring is good here. It catches the literal strings. So the production shape is not vector versus keyword. It is vector plus keyword plus metadata filters. And then we merge the ranked lists. And the merge has one rule worth knowing. Do not just average the scores. Because a BM25 score and a vector score are not even the same unit. Instead, you let the ranked lists vote. A document that shows up in high in more than one list rises to the top. So the retriever's job is not to pick the final answer. It is to cast a wide enough net cheaply. From 5 million chunks, keep maybe 100 or 150 candidates. Third anchor line. Dense search gives us meaning. Keyword search gives us handles. Real RAG usually needs both. Okay, so now we have a candidate pool, let's say 150 chunks. And the lazy move is just take the top 20 and paste them into the prompt. But if we do that, we are still trusting that rough first search way too much. First stage retrieval is optimized for recall. It is asking, could this be relevant, intentionally loose? Because at that stage, missing the right evidence is worse than carrying a little noise for one more step. But before the LLM sees anything, we need a stricter judge. That judge is the re-ranker. It asks, is this chunk actually useful for this exact question? And here is the actual difference. At high level, in that first retrieval stage, each chunk was already turned into a vector ahead of time at indexing. And when the question comes in, it becomes its own vector too. But the two are only ever compared by distance, one vector against each other. They are never really read together. That separateness is exactly what makes first stage retrieval cheap and fast. The re-ranker does the opposite. It takes the question and one candidate at a time and reads them together in a single pass. So it can notice this chunk is not just refundish, it is enterprise and annual and after April 15, which is exactly what the question asked for. Another chunk also says refunds, but it is for consumer accounts, so it gets pushed down. That is the usefulness a plain distance number could not see. But re-ranking is expensive. We cannot run a heavy re-ranker over 5 million chunks for every user question and still hit a 2-second response. So the funnel is the design. Cheap, wide retrieval first, expensive, precise re-ranking second. In our system, maybe it is a 5 million chunks to 150 candidates. The re-ranker to top 20. Exact numbers will change, but the shape is the point. Anchor line, the retriever asks, could this help? The re-ranker asks, will this help this answer? Now, those top chunks enter the context window. And this is another place where the toy diagram lies a little. The context window is not a database, it is a tray. If we throw 20 random chunks onto the tray, the model may still miss the one that matters. Duplicates waste space. Stale docs create conflicts. Long irrelevant chunks distract. And here is the counterintuitive part. Honestly, this one surprised me the first time I saw it. You would think just give the model more evidence, more chunks. It can only help, right? More context, more chance the answer is in there. But it does not work that cleanly. There is a research they call lost in the middle. When the one important fact sits in the middle of a long context, the model often does worse than if that exact same fact sat near the start or the end. Same fact, same model, only the position changed, and the answer degrades. So, more evidence is not automatically a better answer. Where it sits on the tray changes whether the model even uses it. That is why context packing is a real stage, not an afterthought. Deduplicate, keep the old and the new policies together, put the changelog next to them. Prefer newer effective dates. Maybe put the most important evidence near the beginning or the end. And if two chunks conflict, do not hide that conflict from the model. Make it explicit. In our refund example, the tray should not contain 12 old FAQs and 8 vaguely similar policy pages. It should contain the old policy, the new policy, the effective date, and the new line that says new policy replaces the previous one. This is the point where RAG stops feeling like search and starts feeling like operating a small evidence supply chain. Retrieve broadly, re-rank carefully, pack deliberately. Anchor line, the context window is not a database. It is a tray. What we put on it and where we put it changes the answer. Now we have the right looking evidence in the tray. Are we done? Not yet. Because retrieval can bring the evidence into the room. It does not force the model to tell the truth about that evidence. This is the exact bug from the cold open. Old policy and new policy were both present, but the answer blended them, and a citation beside a sentence did not prove that the sentence was supported by the right version. So, grounding has to be a separate check. Every factual sentence should be able to draw a clean line back to retrieved evidence. And if the answer says approval is required for every refund, show me the source that says that in the current policy. If the old policy says it, cut it. If one source says 30 days and another says 60 days, do not average them. Decide using effective date, version, source priority, or say the sources conflict. The fixed answer should be boring and precise. Before April 15, 2025, enterprise annual refunds were allowed for 30 days and needed approval for every refund. In Refund Policy V3.0, effective April 15, 2025, the window changed to 60 days. The restocking fee was waived and approval is required only about $10K. Each claim has a support line. One more accuracy thing, grounded does not mean true in the universe. It means supported by the provided sources. If the source itself is stale or wrong, the answer inherits that. So, source quality and freshness are still part of the system. This is also why RAG evals cannot be one vibe score. You had to split the failure. Did retrieval find the evidence? And separately. Did the model actually use it faithfully? Different questions, different fixes. And this is not a theoretical. A benchmark called RAG Truth annotated nearly 18,000 RAG responses and still found unsupported or contradictory claims, even with evidence sitting right there in the context. Final anchor lineup for the D part. Citation is not proof, support is proof. So do not walk away with a list of tools. Vector database, BM25, re-ranker, prompt template, eval framework. Those are just parts. The machine is the evidence path. So next time a RAG answer is wrong, do not start by asking which prompt should I write. Walk backward through the evidence path. Did the fact survive chunking? Did the query ask for the right thing? Did retrieval catch it? Meaning and the exact handles? Did re-ranking keep it? Did the context tray place it where the model could actually use it? And did the answer prove every claim? Once you see this way, RAG stops being a magical wrapper around an LLM and it also stops being just vector search. At high level, RAG is the discipline of controlling the evidence. That is the whole thing.